Math 2, section 4.6, we're talking about inequalities in one triangle, okay? You should be on page 239, and up at the top, it has comparison property of inequalities. Okay, this is page 239. Okay, this says A equals B plus C. If A equals B plus C, and A is greater than 0, no, that's C. You have to know your letters. Okay, C is greater than 0, then A has to be greater than B. Okay? This all makes more sense when we actually put in numbers. Okay? So we will do that. Just not yet. Okay. On page 240. Okay. Corollary to the triangle exterior angle theorem. We learned about the exterior angle theorem, and this was actually specifically on page 101 in your textbook. Okay? Now, I don't know if you guys completely remember it, but what that said was, if you have two angles, these two angles right here add to be angle 1. Okay? So again, measure angle 1 equals measure angle 2 plus measure angle 3. For example, if this was 95 degrees, then this would be like, let's say 40, and this would be 55. These two angles add to be the same as this exterior angle. Okay? All right, we're going to move on. You're staying on page 240. Okay. Oh, actually, I want you to go back here really quick. So another thing to think about on this is that if this one, measure angle 1, is measure angle 2 plus measure angle 3, then measure angle 1 has to be greater than measure angle 2, right? And measure angle 1 has to be greater than measure angle 3. So that is the difference between our theorem 17, the triangle exterior angle theorem, and this corollary, triangle exterior angle theorem. Okay? So it's just basically saying that this angle has to be greater than this one, and it also has to be greater than this one. Okay, so on the Got It problem 1, it says measure angle 5. And I would actually have a highlighter out to kind of highlight some things that you're doing. But you have measure angle 5 there, is greater than measure angle C, which is right here. How do we know that to be true? If you were to make this triangle here, measure angle 5 equals what two angles added together? Nate S., are you writing all this stuff down? Okay. What two angles would measure angle 5 add to be? No. It's always opposite. The two opposite angles here. So that would be measure angle C plus, good, measure angle 3. Are we all okay with that? That measure angle 5 is the same as 3 and C. Therefore, if these two add to be measure angle 5, then what? Then measure angle 5 must be greater than measure angle C by the theorem we just talked about. Corollary to the triangle exterior angle theorem. Okay. So far so good? So if measure angle 5 equals measure angle C plus measure angle 3, then that means that measure angle 5 must be greater than these individually, right? By themselves. Okay. So on this one, explain why measure angle 1 is greater than measure angle 2. So we're looking at 1 here, and they are wanting us to compare it to 2. Now, what do we know about 1 compared to 3 and 4? We know that measure angle 1 equals what? Compared to 3 and 4? Measure angle 3 plus measure angle 4. Now let me give you some numbers to hopefully make this make more sense. So if I told you that measure angle 1 is 100 degrees, okay? And then I'm going to tell you that 3 is 55 degrees and 4 is, good, 45 degrees, okay? So we can see there that measure angle 1 is measure angle 3 plus 4. Right? Because 55 plus 45 makes 100. Okay. Now, what do we know about measure angle 2? Which one does measure angle 2 compare to? Measure angle 2 equals the same thing as measure angle what?
3.
Good. And how do you know that? Very good. By vertical angles. So by substitution, you guys, we could end up putting in 2 for 3, right? Because since 2 and 3 equal each other. Do you guys agree with that? So we're going to write that measure angle 1 is greater than measure angle 2 by substitution and using the corollary to the triangle exterior angle theorem. You will not have to write all that out in your homework, but it's important for you to have it in your notes. This is how we know it to be true, okay? Okay, so to recap, we know that measure angle 1 equals measures angle 3 and 4 added together, okay? We know that measure angle 3 is the same as measure angle 2 because they are vertical angles. Therefore, by substitution, we could plug in measure angle 2 here, right? So measure angle 2 plus measure angle 4 would also equal measure angle 1. So by substitution and using the corollary triangle exterior angle theorem, we know that measure angle 1 is greater than measure angle 2. Okay. Now for the more fun stuff. Okay. Page 241. And again, I would have out a highlighter because it will make your life a little easier for remembering things if you have one. So on this theorem it says, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So right here, it is saying that xz is greater than xy. So this xz, so this is our longest side. Okay? They are saying that this longest side is across from your largest angle. So this means that y is our largest angle. So we're going to write this in words so it makes more sense than looking at this. So longest side is across from the largest angle. And we're going to look at some numbers. So wherever your largest side is, And I usually take that side and I draw a line, and you can see that across from the largest or the longest side, you get your largest angle. So y would be your largest angle on this triangle. Okay, and so now we're gonna put this into like an example. Are you ready? No? So I need to wait a second? Wait? Yes? No? No? We're good? Does everybody have this written down? Because I think this makes more sense than what they have written. Okay, I'm moving on then. Okay, still on page 241. Okay, in the directions it says, for exercises 3 and 4, list the angles of each triangle in order from smallest to largest. So what is the smallest number right now on this? 2.7. I'm going to write this as S for smallest, and then I'm going to go medium for the middle, okay, and then L for the largest or the longest. Okay, would we agree that this goes? Okay, so they want smallest to largest. So if you go to your smallest side, which is 2.7, that means that my smallest angle, I draw a line, and my smallest angle will be M. So we're going to write angle M. Okay, now we go to our medium side or our middle side, 4.3. And if you draw a line from that side, it goes to angle L. So the next one is angle L. And then our largest one is across from angle K. So that is going smallest to largest. Okay, example 4 is set up a little differently. You need to draw a picture. So we have triangle ABC. Okay, then you're going to go through and put the numbers there. So AB is 8, BC is 5, and CA is 7. Okay, you need to write those in order from smallest to largest. When you have your answer, raise your hand and I'll come by and check. So smallest to largest with your angles. Good. 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 Okay, I wasn't able to make it around, but you should have ended up with angle A, angle B, angle C. So, smallest, right here. See how this is the smallest, which is 5? If you go to the angle, do you see there where it's at angle A? So that is angle A. The next largest number is 7, and that goes to angle B. And then we have angle C as our last one, which is across from our largest number. Okay, questions before I move on? All right, so now we're going on to page 242. Okay, so basically 242 is the converse, okay? What it's saying is that if you have two angles of a triangle are not congruent, then the longer side lies opposite the largest angle. Okay, so we're just going to write this in plain words. Largest angle is across from the longest side. So previously we did the longest side was across from the largest angle. Now they're saying the same thing goes, that the largest angle is across from the largest side. Alyssa, you getting this? Okay. So in this case, if they said that measure angle A is greater than measure angle B, well then that means if you had measure angle A is bigger, then that means that this side would also be bigger. So we're going to move to the example. Does everybody have that? Okay, so problem 3. It says in the figure below, measure angle S is 24, so let's put 24 by S. Measure angle O is 130. And it says which side of this triangle is the shortest side. Well, we need to figure out what this angle is before we can decide which side is shortest. So how could I figure out the degree of that angle? Okay, so let's add it. 130 plus 24 is 154, and then what do I do? Good. 180 minus 154, I have to borrow, and we get 26. Okay, so which angle is smallest? Angle S is smallest, which is here with this 24, and if we want the shortest side, it's across from our smallest angle, and that side is OX. Do we see that? So 24, this angle, if we draw a line, it goes to this side, which is OX. So we would write OX, and it says to explain. So why? How do we know that is the smallest side? Good. It is across. Very good. From the smallest angle. Okay, any questions here? Well, it's a little bit more. A little more. Not too bad though. Okay, page 243. Okay, so for exercises 5 and 6, it says list the sides of each triangle in order from shortest to longest. So right now, we need to know how much this angle is. What will I do to find that angle? Good. We know this one's 90, right? So 90 plus 30 is how much? 120. And 180 minus 120 is 60. And there is a shortcut for that one as well. If you can do it in your head, that's fine. Okay? And so they want shortest to longest sides. So my smallest angle is what? That's a V, right? 30. And across from 30 is which side? So TU is my shortest side. What would be, yeah, so it says shortest to longest, right? So that's my shortest. And then which one would come next? UV, because it's across from the 60. So 60 goes to UV. And then 90 is TV. Now, if I wrote VT instead of TV, is that okay? Yes. And if you wrote UT or TU, either way you write those letters is okay. All right, so that's my answer. Are we okay with that? All right, 6. What will I need to do? Very good. Draw the triangle. Okay, and we have D, E, F. Make sure you label your triangle. Okay. Measure angle D is 20. E is 120 and F is 40. Okay, so again, smallest to largest. I'm going to give out candy to the first 3 that get it correct. 1, 2, 3. Okay, I'll be right. Hold on. And then after that, I don't know. Okay, let's see if you got it. Good. I forget who my food is. I know, but the first 3 that put them up. We can exchange it later too if you. Okay, so this one you're doing is and so your smallest. So what size is it? So we're doing this.
Are you going? I actually like this.
Okay, so the answer should have been EF or FE, right? And then DE or ED, and then DF or FD. Okay? So again, when you're labeling a side, make sure you're using 2 letters. And so here's our smallest. It goes to this side, which is EF. Okay? 40 is the next one. It goes over here. That is D or ED or DE. And then our last one right here is DF. Do we have any questions there? All right. Okay, staying on page 243. This is actually pretty important. It says for 3 segments to form a triangle, read please, their lengths must be related in a certain way. Notice that only one of the sets of segments below can form a triangle. The sum of the smallest 2 lengths must be greater than the greatest length. So if you notice here, if you were to add the 2 smallest lengths together, 2 plus 2 is not greater than 6. 4 is not greater than 6. And when you're saying not greater than, just so you know, I'm going to write this here. Not greater than is when you have the greater than sign and you put a line through it. That means not greater than. Okay? So we'll end up putting these nots through there, meaning it is not greater than. Now over here, if I were to add the 2 smallest lengths, 3 plus 3 is greater than 5. 6 is greater than 5. So 3 and 5 can make a triangle, but 2 and 2 and 6 can't. And the reason is that the 2 sides cannot match up with a length of 6. Okay, it will not make a triangle. Okay? Now how it actually ends up working, and it's right here, is that the sum of the lengths of any 2 sides has to be greater than the length of the 3rd side. Okay? So, in English, okay, 2 sides add to be greater than the 3rd side in order to be a triangle. And we're going to practice this here in a minute, but I would write that down so that you have it written in English. Okay, and now we are going to move on to page 244 once you have that. Is everybody good? Yeah? Okay, page 244. So it's asking us, are these 3, can they be a triangle when you add them together? So I normally always take my 2 smallest lengths. Okay, you can do whatever you want. It's really 2 lengths. Okay, so 2 and 6. Is 2 plus 6 greater than 9? No. Is 8 greater than 9? No. So the answer is no. These cannot be a triangle. This was your explanation. 8 is not greater than 9. If you want to write that in words, 8 is not greater than 9. No, it was just mine didn't work very good. You only need 1 line through it. Okay, so the next one. On your fingers, tell me if it's yes or no. 1 means yes, 2 means no. Good. The answer is yes. If we take our 2 smallest, 4 plus 6, is that greater than 9? Is 10 greater than 9? Yes. I want to show you something else. Okay? You could have taken your 2 largest lengths. Is 6 plus 9 greater than 4? Yeah. Okay? This is 15 is greater than 4. I could have taken, what's the other combination? 4 plus 9. Is 4 plus 9 greater than 6? Yes. 13 is greater than 6. So do you see how it doesn't matter which 2 sides you take? It will make a triangle if those two add to be greater than the third side that's left over. So this answer is yes, it does make a triangle, and we've shown here why it works. You don't have to write out the words, okay? All right, so on your own here, on number 7, I think this is still on page 244, right? Okay? Show me on your fingers, yes or no for number 7. So 1 is yes, 2 is no. Good. It looks like everybody's got it. So if I were to add 2 plus 3 together, is that greater than 6? No. So 5 is not greater than 6, and the answer is no. What about number 8? Good. Good, good, good. All right. So 11 plus 12 is greater than 15. 23 is greater than 15. So the answer is yes, it does make a triangle. Do we have any questions there? Okay, moving on to page 245. This is where it gets slightly more complicated, so pay attention. I'm going to hopefully help you make this not too difficult. So this says, a triangle has side lengths of 4 and 7. What is the range of possible lengths for this third side? Now, I don't know if 7 is my largest side or if it's not my largest side. Does that kind of make sense? And so this is how there can be a range of numbers that would work, okay? This is how we're going to write it. So 4 plus something has to be greater than 7, okay? And the other option is that 4 plus 7 has to be greater than a number. Does that make sense? Because we don't know what the third side is. So either it has to add here and make it greater than 7, or these two together have to add to be greater than 7 to give you the range of numbers. So we could end up putting an X here, right? So in order to figure out what our missing side should be, what would I do to get X by itself over here? Subtract 4. And so I'd get X has to be greater than 3. Over here, all I have to do is add those together. And what is 4 plus 7? 11 is greater than X. And normally we wouldn't write it like this. You want the X to be on the left. And so, do you see how the point is going to the X? You keep the point to the X and you have X is less than 11. You have to write this as a single statement. Whenever you're writing a single statement, you do your smallest number is on the left, your largest number is on the right, X goes in the middle, and then both of these are less than signs. That means that your value could be any number between 3 and 11 for your third side and it will work. Could I use the number 12? No, because if I had 12 here, 4 plus 7 is 11. 11 is not greater than 12, correct? Could I use the number 3? No, because 4 plus 3 is 7. Is 7 greater than 7? No. But I could use the number 4, I could use 5, I could use 6, I could use 7, all the way up till 10, because 11 wouldn't work, okay? So this is my answer. I can have any number in between those two numbers, okay? So now you guys need to try this one on your own, okay? We're going to set it up the same way as we just did this one, and you need to write your answer the same way, okay? I'm going to give a handy out to the first 3 people that get this one right as well. Okay, 1. Two. All you have to do is flip it, smallest to largest. Okay? Okay. Oh. Okay. Close. That one's not right. Okay. You should have ended up with 5 and 41. And then it should be 5 I'm just going to write it here for a minute. 5 is less than x is less than 41. So that means it could be any numbers between 5 and 41. Now how you should have set it up is this. You guys ready? So 18 plus something is greater than 23, and 18 plus 23 is greater than something. Okay, we can put x's in here. Here you'd subtract 18 to get x has to be greater than 5. Here you add those together, and if you want to, you can put that underneath there, and you get 41 is greater than x. When you write it, which number is smaller, 5 or 41? 5. 5 is less than x is less than 41. You always use a less than sign, smallest to biggest. Okay? Do we have any questions? Okay, I want us to do this lesson check here real quick. We're going to skip over here. So, number 11, what is your longest side? Okay, I know this is 95. Do you guys agree? Which means that these two are going to be smaller than 95, right? Because those two add to be 85. So the longest side has to be across from that 95, which should be BC. Okay, which angle do you think would be the smallest? Angle C, because we know this is the longest side, we could give this a number of 6. Do you see how between 4 and 5, which one's smaller? 4 is smaller, right? So that would have been angle C. And could a triangle have lengths 4, 5, and 10? No, why not? Because 4 plus 5 needs to be greater than 10, and 9 is not greater than 10, so that answer is no.